We've been studying about probability, and now we're going to use some of that and look at data displays. We're going to look at specifically two-way frequency tables, which is a way to show data from one source that falls into two different categories. One category is represented by rows in the table, and the other is represented by columns. We're going to look at relative frequency, which is the ratio of the desired event to the total outcomes. Kind of sounds like probability. And probability distribution, which shows the ratio of the desired event to total outcomes in a frequency table. Now, we have 20 people who were surveyed asking their favorite type of movie, and the results are shown in the bar graph. What is the probability that a person chosen from those surveyed did not choose romance as their favorite type of movie? Well, if you remember, probability is favorable, what you're looking for, over total amount of outcomes. And in this case, we're looking for, our favorable is people who did not choose romance. So not romance is our favorable over our total. So if we put some numbers to this, we total up all of the people in the survey and how many chose each category. We know that the people that did not choose romance could be represented by the total minus the people that did choose romance, which was 6. So 20 minus 6 would give us the people that did not choose romance, and there were 20 people in the survey. So that would give us 14 out of 20, and remember, we want to represent this in as a fraction in simplest form, a decimal, and a percent. So 70% probability that a person chosen from this survey did not choose romance as their favorite type of movie. Now, Tracy's exploring the question, what are my chances of traveling to a foreign country? She researched this by taking a survey of fellow students at her school, and the results are in the table. This is an example of a two-way frequency table. We have columns that represent traveling to a foreign country and not traveling to a foreign country, and rows that represent number of males and females in each category. So using this table, find the probability that a person who took the survey has traveled to a foreign country. Well, in order to do that, we would need to know how many total people travel to a foreign country, and so we're going to add up that column, and we get that there's 24 of those. And then we have to have a total of all the people surveyed, which, and if we add up all those numbers, is 105 people. So the probability of a person traveling to a foreign country is 24 out of 105. If we reduce that, it is 8/35, which is 0.23, 23% probability that a person who took the survey traveled to a foreign country. Okay, using this same data, find the probability that a person has not traveled to a foreign country given that they are female. Okay, so looking at this, that means we only want to look at female numbers. So we're going to total up the row that is female, and we have 50 people in the survey that were female, and out of those, only 35 have not traveled to a foreign country. So 35 over 50 would give us a probability of 70% that a female in the survey has not traveled to a foreign country. All right, here's another two-way frequency table. Eric is wondering what his chances are that he will become a lawyer. He researches the ACT scores of lawyers to make a comparison with his own ACT score, and the results are in this two-way frequency table, which shows lawyers in Missouri, lawyers outside of Missouri, and various ranges of ACT scores. Find the probability that a lawyer had an ACT score higher than 29 given that the lawyer is in Missouri. Well, that means we only want to look at Missouri numbers, and we only want to look at Missouri lawyers that scored above a 29. So that would be 5, and then we have a total number of 25 Missouri lawyers in this survey. So out of this survey, there is a 20% probability that a lawyer scored higher than a 29 on their ACT. Okay, again, using the same data, find the probability that a lawyer's ACT score was in the 20 to 24 range. Now we're talking about the entire survey, so all of the attorneys or lawyers and those who scored in the 20 to 24 range. So let's total up that column. So we have a 10, and then we have a total of 36 lawyers total. I guess it's kind of redundant there. So what we have is 10 out of 36. And that is a 28% probability that a lawyer in this survey scored 20 to 24 on their ACT. Okay, Jeff is wondering about the chances that the Kansas City Chiefs will make the playoff this season. And he has a two-way frequency table here that compares wins and losses, the Chiefs' current season and their 2016 season. Find the relative frequency of Chiefs wins for both seasons. So we need to add up all of our wins and compare it to the total number of games played in this survey. And if I add up all of my games, I've got 9. And for the current season, I have 5 out of 9, which is 0.56 or 56% probability. And for the 2016 season, I have 2 out of 9, which is 0.22, which is a 22% probability. Okay. Now, using the same data, find the relative frequency of Chiefs losses given that it's the current season. So we're only looking at the current season and the losses that we had that season. Well, according to when this table was made, we had 0 losses out of a total of 5 games that season. So the probability or the relative frequency of losses is 0. Find the relative frequency of Chiefs wins given it's the 2016 season. So we're comparing 2016 wins to the total games played in 2016. And there were 2 wins out of 4 games played in this survey. And that gives us a 0.50 or 50% relative frequency. The data collected for students at LNHS show there are approximately 497 freshmen, 421 sophomores, 395 juniors, and 372 seniors. What is the probability distribution for these data? That means we don't want just numbers. We want to know what percentage of students fall within each of these categories. And to do that, we need to total up all of those numbers, and we get a total of 1,685 students at LNHS the year this was created. So we're going to find the probability or percentage of students at each class level. So for freshmen, we know there were 497 freshmen out of a total of 1,685. So the percentage of students that were freshmen is 0.295. Let's round to 3 decimal places. Okay, we're going to do the exact same thing with sophomores. We're going to take our total number of sophomores and divide it by our total number of students. And we're going to do that with juniors and seniors. Now we're going to change these into percentages and put them in our probability distribution here. So out of freshmen, if we take 0.295 and round it, we're going to get that is 30%. Sophomores were 25%, Juniors, again, we're going to round to 23%, and seniors will round to 22%. Now, when you're making a probability distribution table, you need to make sure that your probabilities always add up to 100, and in this case, ours do. Now, find the probability that a student chosen at random would be a freshman at LNHS, and we have already done that. It would be 30%. Okay, I think you now have what you need to go forward.